How's it going, everybody? And welcome back to our Cisco Enterprise series, where in this video we're going to go ahead and do a couple of iterations of port channels. We're going to take a look at switch 2 and switch 1 on gig 00 and gig 01. We're going to go through the process of doing a static port channel first. Then I'm going to go ahead and do a LACP based port channel, Etherchannel port channel, same thing. Once I have that in place, we have layer 2, then I'm going to flip it over to layer 3. At least I'm going to attempt to do that. The last time I tried this on this version of code, I don't believe that it worked, but worst case scenario, I could rip the config out and rebuild layer 2. I'm going to keep it in place once it's there. And then we're going to be taking a look at the load balancing algorithms. We'll just take a quick peek at what those are, and then how would you enable misconfiguration guard. So with that being said, let's go ahead and get that out of the way. And then I'm going to pull up the CLI, and we're going to get this party started. Okay, with that being said, let me go ahead and get out of the way, and we're going to start on switch 1 and work our way to switch 2. So when you're dealing with the configuration, again, this is going to be a static configuration. We're going to just do a quick do show interface trunk, and we know that gig 01, gig 00 and gig 01 are trunks, and all that good stuff that goes along with them. Now you'll notice that the gig 01 has more VLANs available to it than gig 00 does. And if we look at switch 2, show interface trunk, we'll see the same thing. It's just the opposite. So what we need to do is keep that in mind when we're configuring this. So they should match. And if we do a show interface status, we both have them as speed auto, which is fine. So I'm going to start on switch 1, and I'm going to go type in interface range gig 0/0 through 1, and I'm going to come in here and type in the channel group is going to be 1 and hit mode on. That is how you configure a static port channel. So I'm going to do that. It's automatically going to create the port channel interface for me. I don't have to do that beforehand. It says the line protocol for this port channel is up, and if I do show Etherchannel summary, we're going to see that both interfaces are up. Now I'm going to go over to switch 2 and do the exact same thing. I'm going to go to interface range gig 0/0 through 1 and type in channel group 1 mode on, and that's literally all you have to do. It's a very easy configuration. The port channel has been created. And if I do show Etherchannel sum, we can see that both interfaces are aggregated. We are a layer 2, capital S, capital U indicates that this is a layer 2 channel, and it is currently up or in use. And then the P in parentheses here means it's been bundled in port channel. So there you go. So that is basically how that comes into play. If we do show interface trunk now, what we should have happen is gig 00 and gig 01 are logically going to go away and be replaced with port channel 1. So we can see that across the board. So we're good to go there. Same thing with switch 1. Do show interface trunk. And if I do show interface status, you're going to see the port channel 1 is down at the bottom here. Everybody's happy. So that is how you create a static port channel. Fairly simple. So the next configuration we're going to take a look at is I'm going to go ahead on both switches. I'm going to go ahead and say no interface port channel 1. That'll get rid of the configuration on both sides. So no interface port channel 1. Go back to switch 1. The interfaces will flap, and then they will come back online momentarily once they start to recover. Usually takes a couple of moments. So do show interface status disabled. Okay, so do show run interface gig 0/0 through 1. Do show. Oh, it's because it's Catalyst. Do show run interface gig 0/0. It's shut down. So we'll type in interface range gig 0/0 through 1, no shut, bring them back online, and then interface range gig 0/0 through 1, no shut, bring them back online. Okay, now it's back up, do show interface status. So that's my mistake. I am accustomed to Nexus, where if you do that in Nexus, if you type in no interface port channel 1, it removes the logical configuration and it removes the configuration at the interface level, but it doesn't take down the interface. So it makes it actually easier to work with. So now that we've got that part done, I'm going to go back underneath here. I'm back underneath the physical interfaces, and I'm going to type in the channel protocol is going to be LACP. And then I'm going to hit the enter key and then type in channel group 1 mode, and I have active and passive. So let me talk about that for just a second. So you have active and passive. So let's talk about passive first. So passive literally means you are going to become a port channel if the other side is telling you to become a port channel. And how do you become a port channel if you are sitting there waiting for somebody to tell you to do something? Well, you have to wait to be told. Where active is enable LACP unconditionally, meaning I'm going to tell you to become an LACP negotiated port channel. So switch 1 I'm going to set up as passive, just so you guys can see the difference. That creates the port channel. And if you notice, if you give it a couple seconds, nothing's really going to happen. The port channel should come online, but beyond that, it says LACP not currently enabled on the remote port. So it's not detecting any LACP BPDUs. So the same, the BPDU that we talked about in spanning tree to detect loops in the network, well, we have a very similar one in LACP for sending the LACP packet, I should say, the BPDU, the frame, over across the wire. So what I'm going to do is on switch 2, I'm going to come in here and type in channel protocol is LACP and channel group 1 mode active. Okay, so that's going to create my port channel, and then we should see that the interfaces on the port channel come online. They do. Interface line protocol came up, changed state to up, and then if we do show Ether C summary, we can see the port channel is up. If we come over here to switch 1, we can see the port channel is up. Do show Ether C sum. That's good. And everything else is looking good. So that's how you create a LACP enabled port channel. It's very, very easy. The key thing that I want you guys to remember here is that the interface configuration has to be the same for as many members as you're doing. So there's a question, what if they're misconfigured? What do you do then? Well, the simple answer to that question is you need to make sure that they're the same. So I've had situations in the past where there's a misconfiguration. You have one side is, there's a thing in Nexus called the back-to-back VPC. The simple answer is you're running 4 switches. You got 2 here and 2 here, and they are linked together. Let's say you've got 1 link from each switch coming down, and the idea is you want to form a port channel between 4 switches. Totally possible to be done. Well, I had a customer a while back where we were in the middle of a migration for them. I had done most of the heavy lifting for them, and the last piece was to set the back-to-back VPC up. The customer engineer said he had it, no problem. I said, if you have any problems, give me a call. So we were still within our maintenance window, and I ended up leaving to go somewhere. I had an errand to run, and my phone rings. I answer the phone. He tells me that there's a problem. He can't get the port channel up, and so I said, okay, here's what I want you to do. I want you to do a show run on all 4 switches and make sure their configuration at the port channel level, the interface port channel, so the do show run interface port channel 1, make sure that this configuration is the same across the board. What he had in place was a trunk allowed list configured. And what was happening was there was an inconsistency on one side versus the other, and because LACP is involved, the port channel wasn't negotiating. So once he cleared that up, the port channel came online. So just be cognizant of those things when they happen. So that's how that comes into play. So that's a layer 2 port channel with LACP. The next thing I'm going to show you guys how to do is I'm going to attempt to flip this guy over to a layer 3 port channel. So I'm going to type in interface port channel 1, and I'm going to type in no switch port. Okay. So I don't know if this is going to work because the last time I tried this, interface port channel 1, no switch port. Port channel state to up. So do show interface status. Okay. So do show IP interface brief. The port channel itself is up. Interface range gig 0/0 through 1. No shut. Okay, that brings the interfaces up. Good. Do show interface status. Now, if I do a do show interface trunk, port channel 1 is going to go away. Let me go all the way to the bottom here. Port channel 1 goes away because now we're trying to do a. So the interfaces go down. Interface range gig 0/0 through 1. No shut. Bring them online. So they're up. Now I have what will be a layer 3 interface. Do show IP interface brief. You'll notice that this guy here now it says up and up. And if I do the show interface status, it's telling me that port channel 1 is now routed. Switch 2, same thing. Do show interface status. It's now routed. So what I'm going to do here is interface port channel 1. I'll do that switch 1 first. So interface port channel 1. And I'm going to type an IP address here is going to be, we'll grab, let's see, what subnet do I have? /22. So 5/22 is what, 4? Yeah, 4 subnets. So I'll just grab something out of the server VLAN. I'll type in 172.31.9/25. So from our subnetting video, I'm going to grab 127 would be the broadcast, so we'll grab 125 and 126. So let's be 125/30. Okay, and then we'll do the same thing over here. We'll type in IP address here, it'll be 172.31.9.126/30. So do show IP interface brief. So we'll be ping 172.31.9.125, and that should ping. Hopefully. It may not. I might have my math wrong on the subnetting, but do show ARP. There's the problem. Okay, so there's no hardware address, so it's pulling in that. So, which is what I thought might be the problem. So I couldn't remember why it didn't work. Like the configuration's there to take it. So what I'll do is I will go to interface port channel 1. And I'll just type in switch port. Switch port, and then switch port trunk and cap .1q. Switch port mode of trunk. And then we'll go do show interface status. Now they're configured. Port channel, the VLAN is unassigned, so do show run interface port channel 1. And then we'll do the same thing on switch 2. Well, let's do show run interface gig 0/0. Still LACP, good. And then, oh, I see. So that there's no channel group number. So we'll have to fix that. So, well, before we didn't make the change here yet, so we'll do show run interface gig 0/0. LACP is there. I might have to turn that off. You might not need to run it because normally when I normally don't do layer 3 port channels. It's not a very common configuration for customers that I work with to run. So what I'll do is I'll go back over here to interface range gig 0/0 through 1 switch port or channel group 1 mode passive, and over here interface range gig 0/0 through 1 channel group. Actually, I need to type in interface port channel 1 switch port. switch port trunk and cat.1q, switch port mode of trunk, and then interface range, and then channel group 1 mode path or active. So it looks like switch 1, yeah, so it's just waiting for the configuration to come across. So we'll just wait for that to happen. Do show run interface gig 0/0. Okay, so do show interface status. Good. Do show IP interface brief. Good. Do show ether summary. So it looks like everything's there. Do show ether summary. Okay, it looks like it's there. Show interface status. Okay, show interface trunk. Okay, it looks like it recovered itself. Cool. So that is essentially that. So with that being said, the next stage in the process was we have a port channel set up between switch 1 and switch 2. And what I would do beyond this is you could create a loopback and put a static route just to ping across it, is to see if it's actually forwarding traffic. Because if I do show interface port channel 1, I do have a MAC address, and you can see that the ether channel is pulling in the BIA, the base MAC address of the switch itself is what it's pulling in. So that's what I would expect to have happen. So beyond that, that's really the only major thing that I would be concerned about. Remember when we had the logical layer 3 interface, there was no MAC address. So therefore ARP wasn't resolving. So there's that. So with that being said, we've taken a look at LACP and static. We've taken a look at layer 2 and layer 3. So let me jump out of here and do a if I type in LACP question mark system priority. No, that's not what I want to do. Yeah, it's load balancing. No, it is Etherchannel. No, I don't remember what the. Oh, you know what? Interface port channel 1, and then underneath here is where I would do the port channel standalone disable. No, that's not it. I'm trying to remember where I would do the load balancing, because like I said, I never use it. Let's do a quick Google search, and we're going to say LACP port channel load balance. And it's telling me, bring this over here real quick, it is telling me okay, Catalyst OS. Let's see here. Catalyst iOS. What is iOS? What's the configuration for iOS? Oh, that is super helpful. It's like, yes, you can do it, but let's say to 3750. Okay, here we go. So you can configure load balancing forward with port channel load balance. Okay, that's what it is. Okay. So I don't remember the command, so it's going to be exit out of here. So port dash channel load balance, and then the different load balance thing. So you can do destination IP, destination MAC, source destination IP, source destination MAC, so on and so forth. So if I was to do a show run all section port dash channel, so it's doing source destination IP. So it's doing this one right here. It's an and or. So that's what it's doing. So it's based off layer 3. If you didn't like this for some reason, you could always change it to something else. So this is how you would change the load balancing mechanism. Okay, so there's that for load balancing. And then the last piece that I'm going to talk about is going to be the Etherchannel misconfiguration guard. So if I came in here and type in error disable, and we say recovery cause, and we come down here, we have this channel misconfig right here. And if you have a misconfiguration error, you can enable this, and then it'll try to recover it, but you also have the detect cause, and you could do, I guess you can't do it here. So it's just a recovery. So you could recover from an error if you wanted to. So recovery cause channel misconfig, and then associate the command there. So you could configure it if there's an issue. The reality of it is you really don't want, so this is the recovery of it. So if there is an issue in the network where the port channel goes down, then there's, in my opinion, there's two schools of thought with this. You want the port channel to stay up to pass traffic, right? But in other cases, you may want the interface to go down, so you get an alert, take a look at what's going on. So it's just one of those things where you just have to be mindful of what you're implementing when you're doing that. I would recommend, if you do want to play with that, go do some research on it. And in this particular case here, there are certain capabilities that are really only able to be done in hardware. So this would be one of those cases where if you really want to test out Etherchannel misconfig guard, you really need, because then you can get down to the speed and duplex and stuff like that, where speed and duplex really doesn't work in a virtual environment. So it's going to auto for the majority of stuff and come up when it needs to. But this would be one of those cases where I'd say go ahead and just order some cheap switches off eBay and play around with it. At least that's how I would be here based in the US. I've gotten plenty of comments where so-and-so is based in wherever, and eBay just doesn't make sense for them for shipping. But if you can get a hold of some hardware, play around with that. My honest opinion, and this goes back to another topic here I want to talk about real briefly as well, is UDLD, the unidirectional link detection. This is going to be used with fiber, where you have you get a fiber going out and a fiber coming in. So you have a send and you have a receive fiber, and you want to protect against one of those particular sender or receiver from failing. Unidirectional link detection. If you have a problem there, that's a big problem. So I have had that happen to me a couple of times. One time was, paint the picture here. This was a larger facility, and they had very, very long fiber runs. So we had structured cabling that was put into place by a vendor that the customer used. This fiber went in, and so the way that you normally look at this, and then I'm going to get out of the way here and try to do a little bit of whiteboarding here so you can understand where I'm coming from, because this is actually going to come into play, quite honestly, more often than not when you're dealing with this type of configuration. It's more specific to Ether channels, but okay, so these are a couple of the examples that I wanted to talk to you about real quick. Is you have these fiber patch panels that you would bring in, and so you'd have structured cabling. So in this case here, they're doing a simplified version of it, but essentially what would end up happening is you have a location where you're going to have structured cabling. So company is going to come in and run all the fiber for you in between your closets. They're going to deliver this fiber to where you need it to go, and then they're going to deliver these fiber strands to this, and they're going to plug it in the back side of this connection right here. So this is just a close-up, and then you're going to plug your fiber into the front of it. So one of these two, so top or bottom, is going to, when you look directly into it, you're going to see one is lit up with a red light, the other one is not. So the one that's lit up with the red light is going to be your receive. So you're going to have to marry that connection to one of the interfaces here on this particular switch. So on the switch port, you're going to have an SFP plugged into it, and you're going to have a fiber module plugged in, right? And you're going to have your SFP, your small form factor pluggable. And then if you look into that, one of its lights is going to be red, the other one is going to be not lit. So you're going to take the fiber, whichever one is lit up, and you're going to have to line them up. So not lit on the switch port is going to be the one where it's lit coming in from the fiber patch panel. That's going to go into the non-lit, and then the lit coming from the SFP is going to go into the non-lit on the patch panel. And this is how you would marry it up. So you just have to match the polarity on the interface. And when you do that, that's going to allow you to tie that in. And then you'll start to see linked lights come online. You'll start to see the interfaces flicker and all that type of stuff. Another example of this is going to be another fiber patch panel that's out there. This one is one you could install into a rack. And so this is like a double-sided. And again, one of these is going to be lit, the other one's not going to be lit, and you just have to match the polarity. This is another one where this is a very common one that I've seen, where the provider will dump in the fiber strands, and this one's actually pretty heavily loaded. There's a lot of fiber strands in here. Normally I'm dealing with 8, maybe 10, 12, 14, something like that, not as many. And you just have to line them up on these interfaces. So that's essentially what you would end up doing. So when you do that, that is going to be what ties in your connectivity. So unidirectional link detection is there to identify scenarios where, like, you have your connection, so you have a send and receive. Well, I should say you have your send and you have your receive, and if one of those connections is to fail, there should be you should be sending laser lights back and forth on each one of the connections on that connection. So there's going to be 2. You should be sending both at the same time. So it should be bidirectional when it's operating correctly, unidirectional when it's not operating correctly. So UDLD is going to come into play with stuff like that, where it's very possible that you're running a port channel over the top of that. So UDLD is going to be looking at layer 1 connectivity. Port channel is going to be looking at bundling layer 2 and above. So that's where that comes into play. So hopefully that provides you guys with a solid understanding of how all that type of stuff comes into play. And that is what I really wanted you guys to understand about how all that type of stuff operates, and go from there. So with that being said, ladies and gentlemen, that is all I have for you in this video. If you have any comments, concerns, questions, what have you, please drop a comment in the comment section below. And if you haven't already done so, please like, share, and subscribe. And I'll catch all of you fine people in the next video.